Okay, so today we're going to talk about acids and bases. And the reason we're doing it in this order, we're doing equilibrium first and then acids and bases, is because weak acids and weak bases have an equilibrium state, whereas strong acids and bases do not. So for example, real quickly, hydrochloric acid, which is a strong acid, does not have an equilibrium state. So it only goes in one direction because it dissociates 100% into its hydrogen ions and its chloride ions. So if I put aqueous hydrochloric acid into water, it will dissociate 100% into hydrogen and chloride. Now, why is hydrochloric acid considered an acid? Well, it's because of this hydrogen. Any compound, any molecule which dissociates and delivers hydrogens is considered an acid. Okay? And it is this concentration of hydrogens that determines how strong the acid is. So the hydrogens are going to dissociate into moles of H plus per liter of solution, right? And so that is going to give what we call the concentration of H plus. Remember, these boxes show concentration, and that is equal to moles per liter. Okay, moles per liter. So when there's a dissociation here, it dissociates into moles of H plus per liter. Now, see how this hydrochloric acid is in aqueous, and so therefore the hydrochloric acid has a dissociation, a concentration also. So let's say, for example, I said, okay, I have a 0.10 molar, okay, hydrochloric acid. That capital M here, the capital M, means moles per liter. So that means that what I have here is a 0.10 moles of HCl per liter of solution. Okay? So now what I want to know is what is the concentration of H plus in the solution? So what's going to happen is, okay, the HCl, here's your answer, the HCl is going to dissociate, into H plus, AQ, plus Cl minus, AQ. I know this because it's an acid. It's got H first, right? That makes it an acid. And I know that this is 0. Sorry, this is 0.1 here. I made a mistake. This is 0.1. You know me. This isn't 0.01. This is 0.1. 0.1. 0. Okay, so this is 0.10 molar. And so because there's a 100% dissociation for every 1 mole of HCl that dissociates, I'm going to get 1 mole. And it's 100%, so there's not going to be anything left over. So that means that I'm going to have a 0.10 molar HCl and 0.10 molar Cl minus. So what is the concentration of the H plus? Well, the concentration of H plus is equal to 0.10 molar. That is the concentration of the H plus. Okay, because it's 100%. It's a strong acid dissociation, so 100%. Now, not all acids are strong acids, but for our purposes right now, we're going to say that they're all going to dissociate 100% because we haven't gotten any deeper. So whatever the concentration of the acid is, that's going to be the concentration of the hydrogen. So these are acids here. We know this because acids produce H plus. Okay, that's why they're acids. What about bases? These are all acids here. What about bases? So bases do something different, and I'm going to make bases green. Okay, bases do something different. If I have a sodium hydroxide, and that is going to dissociate into sodium, which is going to be aqueous, plus OH minus. And that is also going to be aqueous. Okay, and so this is a hydroxide, which makes this a base. Base. So this is a base because, okay, it is the hydroxide. And so that makes it a base. And so this is going to be in moles. Again, we're going to get a concentration of hydroxide, which gives us a moles of hydroxide. OH minus per liter. And so that's going to tell us how strong the base is. Now, why hydrogen and hydroxide? So this is a little bit, to explain this, it's important to note that water, so this is a base, right? Base, which is to hydroxides, OH minus. So acids are H plus and hydroxides are OH minus. But why these? Why H plus and why OH minus? Well, the reason is because water dissociates with an equilibrium into H plus plus OH minus. So here, in water, which is neutral, as we know, dissociates into H plus and OH minus, and it is at an equilibrium. So constantly, water is going back and forth into H plus and OH minus, back and forth, and back and forth. And in, say, a drop of water, there are billions and gazillions of molecules of water that are all different states of this. Some of them are over here with the H plus and the OH minus. Some of them are over here with the H2O. And so because of this, that is how water stays at a pH of 7, a neutral pH. And so the H plus is the acid, the OH minus is the base, right? So the H plus is the acid, the OH minus is the base, and then the water is neutral. And so what we get is we get an overall neutral. And so if you have more H plus, if the concentration of the H plus is greater than the concentration of the OH minus, the solution is acidic. If the concentration of the OH minus is greater than the concentration of the H plus, then the solution is basic. okay? So let's take a look at what some of these concentrations might look like. So for example, these concentrations could be very, very small. So a concentration of H plus could be as small as, 10 to the minus eighth, right? And the concentration of the OH minus in that case would be equal to 10 to the minus sixth. And in this case, which one is larger? Well, you can see the concentration of OH minus is larger, so this solution is basic. Okay? So that's the way this goes. Now, but this is kind of hard. There must be a way to judge. I mean, what if, so this is really, well, let me say this. This is really easy. I know that 10 to the minus 6 is larger than 10 to the minus 8. So that's easy to see it's basic. Right? But what if it wasn't this easy, first of all? And what if it was, I wanted to see exactly how much larger it was? What if I wanted a scale that was easier to work with? So we have a scale that's easier to work with. The scale is called the pH. So we have the pH scale. And the way to find the pH, and this is important, the pH is equal to the negative log of the concentration of the H plus. Okay? So this is super important. You get to use a button on your calculator you don't use very often. The pH is equal to the negative log of the H plus. So if my and the pH scale runs from 0, which is acidic, to 14, which is basic. And I always think like, well, how am I going to remember that? And I always think, well, it's in alphabetical order, so, A to B, right? And in between is 7, which is neutral, because it's halfway between, and this is water, right? Water is neutral at 7. So let's take a look at this right here. And what is the pH of this solution? Well, I'm going to take the pH of this solution. So the pH is equal to negative log of 10 to the minus 8. And you do this on your calculator. So on my calculator, small little minus sign, negative, and then log, and then in that parenthesis, I'm going to do 1, oops, no, not that, sorry, okay, negative log 1, and then I'm going to say E8, negative 8. So that's my 10 to the 8th, however you do it, but that's my 10 to the 8th, right? Close my parenthesis, and I get 8. So we knew that. I mean, that's not anything major, right? So we knew that. So my pH is 8, which puts me in the basic range, right here, in the basic range. Okay? All right, so let's do some practice problems.